And Radek will talk about composable data for a better and more powerful web. Let's give Radek a round of applause.
Yeah, unfortunately, I probably need to stand here instead of just like closer to you, but I need the computer to know what I'm talking about. This is me. I'm Radek. I'm a senior developer advocate at Ceramic, and I will talk a little bit more about composable data and how Ceramic works on that problem and solves that problem. So Ceramic is a protocol, and it also has a ComposeDB product kinda on top of that protocol. And to add even more to that, it's like a composable graph database built for Web3 app developers. So there's a lot of that, and I will focus on each and every aspect of this so that it doesn't seem like just a bunch of words thrown together for hype factor. So I will explain every aspect of this. So for example, what I mean by composable, like the first aspect of that. Currently, in Web 2, for example, or in many Web 3 products as well, the journey of the user is that they come to a product, like for example, social app, they come to Twitter, or whatever they call themselves now, and what they need to do, they need to sign up, they need to give their name, birthday, locations, whatever else. Then they can choose different site preferences, then they have different connections, follows, unfollows, whatever else. So many different features that are valuable, but to this network, like to Twitter, and also to the end user. But when they go to Facebook or Meta or whatever, to social app B, then they need to, from the end user's perspective, they need all the same as from Twitter. They need to be able to follow people that they're interested in. They need to be able to maybe not even sign up quickly, but just like use their currently existing profile. But they need to do everything from scratch. They need to give their name, birthday, everything else. They need to add all their friends and so on. So this is where composability comes in, where if you could use all of this information, or like maybe not all of this, where this overlapping information, like your user profile or your friends list. This could be public, this could be on-chain or like available, verifiable and so on. And this could be reusable. So that's the composability aspect of this. Ceramic solves it this way that it has different data models, and data models can be for everything. Like one of the data models could be for a basic profile, and that profile can be like very detailed. It can have any aspect that you want, like name, last name, birth date, location, anything else. And then you can use whatever you want from that model, or reuse what the user already has entered previously elsewhere on social app A or social app B, and then it's just if all of the needed information is already there, it's just like logging in instead of signing up. We split it into data model, where you have the data model description and a link, and then the link is with all the schema, like I said, so that name, email, potentially password, whatever else. So that's how it works. And then we provide a way, like Ceramic provides a way to read that data, create that data, and update that data. And all the other apps can read from that, can use this protocol to interact with that data, which is shareable and composable. And here are some of the use cases, like core components of sovereign data. So where it makes sense, it definitely doesn't make sense everywhere. Definitely doesn't make sense for like financial data and so on, because all of this is public. There is a way to also send and share encoded data, private data, but that's not the primary use case. The primary use case is composability, where it's public and many different apps can read and write to that data. So one of the most exciting recently use cases is, and more important, is reputation. So aggregated identity and reputation. So I am active on many different platforms, Twitter, Meta, whatever else, in Web 2. But in Web 3, I may be active in DeFi, social app, Lenster, whatever else. And the more places I am active at, the more my aggregated reputation should grow. But this is this is not integrated at the moment. This is all pretty much siloed. Everything, every platform, every service, everything is siloed. So there is a need, and there is a growing need for reputation in Web3, so that I can trust, as a user, I can trust the service provider, and then the service provider can trust me that I'm actually a user, not a bot or a scammer, for example. And for this, like, composability is an ideal use case, because it's all public, it's all verifiable, it's all on-chain. You can verify the actions, you can verify when those actions happened, and you can verify that this data is true. Social infrastructure, you can build a whole social network on composable data. It will not have some private messages, for example, but this is also, you can do it with encoded data, but like I said, it's not the primary use case. Public data graph, document storage and everything else. So the way it works right now, so all the data is stored on IPFS as a layer 0, and then there is a whole protocol on top of that, like Ceramic protocol, that has IPFS for storage, but then does everything for composable data and so on. So storage is cheap and fast, and yeah, we have built it so that it's much faster than even L2s or L3s or whatever else. And it's like almost like your local database. Other things, that open source data models. So this is another one that is more and more popular that we see as a use case. Discovery, metadata and schema, or like scientific data put on-chain, actually not on-chain, but verifiably true at that specific moment by that specific user, which is important for scientific research. And then other scientists, other researchers can use that data and contribute to that data, and everything stays in one place, as is shared among the research community. So how does it work? So the key component is that Ceramic network is at the very bottom. So this is something that has IPFS as layer 0. Then you can treat Ceramic as like layer 1. So Ceramic is like, it's streams of data. It's like Apache Kafka, but for blockchain. So you have data streams. And you can work just with Ceramic without using ComposeDB, but it's much easier to use ComposeDB. It's like an interface that makes interacting with those data streams much easier and more like your database, where you can just read and write queries and have responses like from database. So that's layer 2 of that piece of the whole pie. And then data composites, it's what you create, like data models and so on. So what you either reuse what's already existed, like a profile or identity or whatever, or like a piece of scientific research. So these are the composites. And here where the magic happens. So how it works. So API hosting is like step one. So there are different Ceramic nodes. You can run your own Ceramic node, or you can clone one of the Ceramic nodes that has the data that you are interested in, and then you are contributing to decentralization of the data. And this is one thing. That so you run a Ceramic node, use another Ceramic node to read the data, and that's where the requests are coming to and from. And then data producers, so for example, if I'm a user, I'm a data producer. I'm connecting to the app that uses Ceramic, for example, and then I send a message or do some action on a social app, or I do some action that contributes to my activity on chain. And Ceramic handles the event storage and indexing as well. And then it's public, globally available, and decentralized, and everybody can use and have access to that data. And the next thing is that it's not just someone gives the data and that's it. It needs to be also verifiable. It needs to be verifiable that this specific user performed this action at this specific time, and we can verify that this was exactly that user. Only then it makes sense. Only then it is equivalent to storing data on chain, which is too expensive for a huge amount of data. So that's what event ordering is doing. So the way it works right now is that on Ceramic, after a specific amount of time, all the events are rolled up with Merkle tree, and then using the anchor service, it's CAS, Ceramic Anchor Service, it's then anchored on Ethereum blockchain, the hash. And using that hash, and it's like periodically with timestamps, with everything, we have that hash. And using that hash at that specific time, we can then decode everything and verify if that user performed that action at that specific time or didn't. So that's how it works when you have verifiable, distributed, composable data. And then the networking, the last one is that Ceramic nodes, you can run your own, you can use someone else's if you want to be sure that you will have access to this data. You clone another one and you keep that in sync, and yeah, it's more distributed this way. So that's more or less the stack of and the whole lifetime of the Ceramic service. And now a few questions that people often have. So first of all is, if that's doing like the I think step 2 and 3 here, if Ceramic does the indexing and works like a database, so is it like kind of the graph which does the indexing, and then you can also query the thing, like all the data and so on? Not at all. So the graph does the indexing. The graph is also using GraphQL, and Ceramic allows you to use GraphQL as well. So that's why people probably have that idea that it's something similar to the graph. But Ceramic only indexes what is on chain. So data on chain, they index that and they give you like the interface to quickly and cheaply get that data. Ceramic does something completely different. It doesn't index data on chain. It indexes data that your app creates or someone else's app creates, which is verifiable on chain, but you can create much more data and then query much cheaper than when storing on chain. So it's something completely different. Ceramic is more like your decentralized version of traditional database. Yeah, the main difference is like, with Ceramic you can store, it's for storing, creating, and having access to as much data as possible. It's like you don't have to think about the cost of your data. It's like building in Web 2, but having all the good stuff of Web 3. So that's the first difference. And the second is now, okay, so if it's not like the graph, so what is the difference between doing it on Ceramic versus doing it on chain? So first of all, it's much, much cheaper to doing it with Ceramic, much more scalable. It is optimized for a lot of data, for quick reading, quick writing, quick retrieval of the data. And it is not optimized for financial uses like blockchain is, so it uses a different consensus model. And this way it's much cheaper and easier to scale than a normal blockchain. It also has better developer APIs. You can build different schemas. Like I mentioned previously, you have models, you have schemas, and you can do whatever you want with that schema. You build your own relations, then you have the GraphQL API to interact with the data. So you can have all the complex queries to retrieve that data, and you don't need to wait for it like with the blockchain. It's almost immediate. And it's also more powerful in terms of access. So it uses DIDs, decentralized identity. So you can use any blockchain wallet to create a DID, and then using that DID, access your account, sign the operations, and also you do it only once. You don't need to do it every time, with blockchain. So Ceramic has all the good stuff of keeping the data on the blockchain, but doesn't have all the bad stuff like slow or expensive or hard to use from developers' perspective. So at the moment, Ceramic has 4 networks that can use for building. In memory is just like for your playing with on your own machine and creating like sample applications. Clay testnet is our main testnet where you can play without paying for CAS, which is this anchoring service which anchors to Ethereum, and mainnet when you already have your app in production and when you need already and use that verifiability and composability, and then it also anchors to Ethereum, so that costs a little bit to run. So that's only when you have a working product. Now the tools to use Ceramic, we have a CLI tool to make your life easier, where you can just fire it up, and we have 7 minutes, nice. I'll show you. So this was the part of why, and now I will show you a little bit of how. First I wanted to introduce why Ceramic makes sense, and second is how to use it. So Will takes you through the whole process and even lets you have a sample social app as a process of onboarding when you can play with different data locally and see how Ceramic works. Or you can use simplified deployments to deploy to DigitalOcean or anywhere else. And these are some of the use cases that some of them I already mentioned. Decentralized identity probably is number 1 in terms of interest right now, where you can store profiles, credentials, reputation systems, and for example, Gitcoin uses Ceramic for their Gitcoin passport product, their main product. Social networks where you can build social graphs, posts, likes, comments, everything that is public. You can build with Ceramic. DAO tools, again, where everything is public and there is a lot going on, and a lot is also depends on reputation of specific users, specific members, specific partners. And you also need to track different proposals, votings, and everything else, and everything is public. and information graphs, like I said, knowledge graphs, science graphs. A lot of research data is on ceramic, so that's another important use case. And these are some of the companies already using ceramic. Many more are onboarding at the moment. I will run a quick demo, but we only have like 5 minutes, so I will show a few maybe interesting slides where I show some relations, like the models. So this is what you would do to install the wheel, and then start the wheel configuration, and then you can either use, so this is how you would use an existing model. So for example, this is the model that is, I think, for a basic profile. So there is already there is a list of different models to reuse if you want, and then you can already use the data that's already there, or just use something for you to use in your own app that someone already has tested and has running. Or you can create your own model from scratch. But for the first one, I think it's nice to reuse to see how it's working. But if you want to create your own model, so this is how you do it. You just, this is basic profile model from the sample app that is being built for you as part of onboarding. You create a basic profile, the create model here. Account relation is either a single or a list. Single meaning that you can only, the account can only have one instance of this model. And if it's a profile, then it obviously only needs one profile per account. But if it's a message or anything else, then you can have as many as you want. So for the profile, its account relation is single, short description, and then different fields here. For simplicity, here only 4, the name, description, gender, and emoji. And then you can see like exclamation point means that it's a required field. No exclamation point it means that it's optional, and you can set all the rules. And that's how you build a model. And then once you have the model, you can have different relations, like in your database, one-to-one, many-to-many, account-to-model, model-to-model, and so on. And this is, for example, how you can define a relationship. First of all, you need you have a basic profile model, and you decide that, okay, I want to reuse the basic profile model, and I want to have access to many profiles that are already on Ceramic, so I will reuse that. But for my own social app, I want to build my own model for posts, because my app is totally different. So I will reuse the basic profile, and I connect my own models, posts model to this basic profile to reuse. And this is where I am defining how those posts will look. And if someone is coming as a user to this app, they will be able to immediately log in instead of signing up, and immediately have access to their social graph, for example, and then start creating content and posts on that specific app. Interacting with the data, you can interact with GraphQL to make it easier, to make it faster, to make it understandable, and to be able to use something that people already know and value. So this is a basic query. 2 minutes, so maybe I'll show 1 or 2. So this is where you create a new post of simple GraphQL stuff. And this is how, I don't know if you can see it. Oh, yeah, it's not good. Okay, so yeah, so this is a more complicated query that I wanted to show, but it's kind of like a database. This has different where parameters, different and parameters, different filtering by different fields, sorting and so on. So basically you create like a database query, you sort it and filter any way you want, and you get the data and you get it immediately and fast. So you don't need to wait, you don't need to pay a lot to access that data from blockchain, from on-chain, because you have it off-chain, and it's basically your database with verifiable credentials, verifiable truth, and also composable if you want. If you don't want it to be composable, you just use your own node and that's it, and don't make it public. Some resources, there's ComposeDB documentation and guides. The QR code goes to ComposeDB documentation. Ceramic.network is our website. There's developer blog, Ceramic YouTube channel. If you don't want to run your own node, like on your infrastructure, you can run it on highernodes.io. And Scan S3XYZ has different models listed available, so like a basic profile model or like a thread model, like for forums and so on. There is a thread model that you can reuse and make that composable. And that's it. That's Ceramic. Thank you.
Thank you very much, Radek. And does anyone have any questions?
Yeah.
Sorry, with Mike.
Hey, thanks for the presentation. Is it possible to check how popular different data models are? So
yeah, so that's on Scan S3XYZ. You go there, and there is an activity tab. I think total activity and the last 7 days activity or something like that.
Okay.
Yeah.
What are the coolest examples you saw people built on top of Ceramic?
Yeah, I think that Gitcoin, what it uses for is a nice, interesting. But I don't think it's the coolest now, but it has the highest potential to be, because they have started it and they have the resources and they have the user base to make it most valuable to both of them and to everybody using that. Yeah.
Thank you for presentation. It was really nice to know all that stuff. But I would like to know, as a developer, how do you approach addressing the content of the database? Because we do this oftentimes by the index or something like that. But in the decentralized world, we often use the content-based indexing, CID, at least in the context of IPFS, which is the most popular database of the decentralized world.
Yeah.
And how does it work in the, well, relational database, I guess, which
So you define the fields, and in the model, you define that in the model which fields are being indexed, and that then is that index is then part of your Ceramic node or the network of Ceramic nodes, and it's being queried based on those indexes. So it's harder to index everything. So especially it's like a large content, like a field with large content. But you choose. It's like with a database. You choose what you want to index. There is a price for that, meaning the price of like probably storage if you want to index a field that is data heavy. But once you index that, then it's available for you in the queries and everything else.
Okay, what if I lie?
Sorry?
What if I lie, just as a node? Is there a way to check if I am honest or not? Because in the decentralized world, that's kind of the most important thing. And if we have the content-based ID, then we can, based on the hash, be sure that this is the thing that we want. So how we can control the node, to be honest? That's maybe. Lastly, my question was wrongly asked, and sorry.
Okay.
That was the point. What I want to know.
So that's based on other nodes. So it's distributed, and if other nodes see that your node is producing data that is not in sync with what other nodes are producing, then they will just stop syncing with you. So you will still be running, you will still be producing your data the way you want, but just nobody will be syncing with you, and that's it. Yeah.
Okay, I think that we don't have more time for other questions, but we can give a round of applause for Radek.
Thank you.
Thank you.